Okay. Today's topic is electrostatic potential energy of a charge in an electric field. Okay. So, just I want to recall now. To recall. Okay. The gravitational potential energy. Okay. What you have studied in your 11th standard. Okay. See, now I have, before going to the electrostatic potential energy, just I want to recall the gravitational potential energy, the old concept. Okay, what you have already studied. Okay. Now let us consider a mass, a source mass called a source mass. Okay. And surrounding the source mass, there will be some gravitational field. Okay. Okay. Now what I want is, I want to find out, see, therefore, each and every point, okay, here, this is a source mass, okay, this is a source, okay, which is producing a gravitational field. Now, and we know very well that each and every point, this is a gravitational field, each and every point in the gravitational field have different strength. The intensity of the gravitational field will be different. Already you know, intensity of the gravitational field at different point will be different. Like that, there is one more concept you have to see, gravitational potential. So, the gravitational potential okay, at the different points, that is, let me consider A, B, C. Okay, so gravitational potential at the different points will be different. Different points, that is, different points which are at different distances from the source. Okay, that is also, what is it? That is different. Each and every point has its own gravitational potential. You know that the source M is positive, always positive. Source is here, always positive. Therefore, as you go towards the nearer and nearer to the source, if you are, okay, the gravitational field intensity will increase. Like that, the gravitational potential will also increase as you go nearer to the source. Okay, this I think you people have studied already. Therefore, what is the potential at A? The potential usually is denoted by, what is that? V, right? Therefore, potential at A is VA. Potential at B is VB. And potential at C is VC. Out of this, because M is positive, the potential M is always positive. Unlike your, what is that? Charge. Okay, mass is always positive. Therefore, you can say that potential at VC will be larger than VB and it will be more. Why? Because C is very close to the point, that is source mass. Okay, right. This is number one. Next one is, what I am going to do is, I am going to keep a test mass M0. Test mass M0 at A. See, if I keep a test mass at any point in the gravitational field, then that mass, the test mass M0, it acquires some gravitational potential energy. It acquires some gravitational potential energy. Okay. Therefore, when it is kept, when M0 is kept at A, it acquires a gravitational potential energy, that is UA. Potential energy, usually it is U, energy, right? UA. And what is that UA? UA is nothing but, what is that? It is M0 into VA. It is M0 into VA. What is VA? VA is the gravitational potential at A. Okay, and UA here is gravitational potential energy at A. Like that, what is UB? UB, that is equal to M naught into VB. Okay, therefore what is U? What is that U potential energy? What is U potential energy of the mass, test mass M naught when it is kept at C? Are you following? It is the potential energy of the test mass M naught when it is kept at the C is UC, and that is nothing but M naught into potential of at C, that is VC. Okay, therefore you can very well say that because M is positive, you can say that potential energy at C, if you compare, you know very well, okay, potential energy of M naught at C, okay, will be larger. Are you following? Potential energy at C will be, okay. Therefore, once again, if I want to move a mass, that is test mass from A to B. If I want to move it from A to B, okay, then its potential energy is changing from where? From UA to UB. Are you following? If I want to move the test mass from A to B. Okay, therefore, what is the potential energy difference of the mass, okay, between 2 points A and B, that is given by UAB. That is nothing but UAB. That is, what is that? It is the potential energy of the test mass, okay, between 2 points A and B in the gravitational field. In the gravitational field that is produced by my, what is that? Source mass M. Okay, and therefore, what is UAB? That is equal to, okay, UB minus UA. Are you following? Therefore, it is the potential energy difference. Okay, therefore, it is a potential energy difference between, what is that? 2 points. Okay, therefore, I think this, I can even say this one, potential energy difference. So, I just don't want this one. This is potential energy difference. I just want to represent by delta U. The potential energy difference, what is that? Of the test mass, okay, between 2 points A and B. Therefore, that is given by UB minus UA. UB minus UA. Okay. Therefore, I think this is, I just want to recall this concept. Okay. The just analogy we will see in our, what is that? The same thing. What is that? The mass. Okay, now you have to replace the mass by the charge and gravitational field here, but there you will, it will be, what is that? The electric field. Electric field. Okay, so now the definition, everything we will be seeing with respect to, I think we already seen last year what is that potential energy difference. Okay, the gravitational potential energy, gravitational potential energy difference, potential energy, everything we have seen. The same thing we are going to see in with respect to a charge, okay, and electric field here. Okay, right. Now, what is next? We'll see. Well, let me run this one. Okay, therefore, shall we go to the this one? Once again, I'll write electrostatic, potential energy of a charge, in an electric field. Okay, for that, now we will see. Okay, just now we have seen the, with respect to gravitational field. Now we are going to see potential energy of a charge in an electric field. Okay, so now what is This is, let me take the coordinate x, y and z. Okay. Now what I want is, I have, see, 2 points, because first here at the origin, okay, I have the source charge plus q, source charge plus q, this origin is O. Okay, now it has, therefore the charge is kept, means definitely around that, what is that, there will be electric field will be there. Okay, right. Now what I want is, I want to take 2 points here. Okay, therefore I have 2 points here. Okay, A and the other one is B, other point is B. Okay, okay, now I am going to keep a test charge Q naught at A, Q naught at A. Okay, therefore when it is kept at Q naught, definitely what, there will be a force of repulsion due to this charge, due to the electric field here, electric field that is produced by the charge plus Q. Okay, therefore definitely what it will experience, what is that, a force in the repulsive force in this direction. Okay, why? Your, this is the repulsive force that Q naught will experience once it is kept at A. Okay, you know that Q naught is a test charge. Test charge itself, already we have seen, it doesn't have any electric field of its own, because Q naught tends to 0. Test charge means it should not have any influence on the original electric field produced by our, what is that, plus Q. Okay, so once I keep it, what will it, definitely it will experience a repulsive force due to the electric field that is produced by plus Q. Okay, but what I want is, I want to move this Q naught, okay, through a very, very small distance, through a very small distance, what is that, dr, through a very small distance, that is dr. Okay, this is dr. Okay, therefore this is dr, which this is dr, this is, okay, small distance dr. Okay, therefore, well, some definitely when I what is that, definitely if I want to move the charge, okay, through distance dr, and the dr distance is towards the what is that, towards plus q. Towards plus q means definitely, what is that, some, what is that, force has to be applied. If I am up, so some external force has to be applied, because if you keep just like it, will move only in the direction of Fe. So I want to move the charge Q naught through a very small distance, that is dr. Okay, dr. Therefore, by applying some external force, by applying some external force, that is F external, I'm okay, and that is very important. So now I am going to apply an external force, okay, towards in the direction, what is it, towards plus q. Okay, which means it is opposite to Fe, opposite to Fe. Okay, therefore for that, what am I doing, I am going to apply F external. But the very important thing is, this F external, the force, should just counterbalance the force due to the electric field, force due to the electric field that is produced by plus q. Okay, it just counterbalances. Okay, why? Why? Because only then you can say force on Q naught will be 0. Okay, Therefore, what is that? If force on Q naught will be 0. Once the force on Q naught is 0, if I am moving Q naught through a distance dr, okay, so since there is no force acting on it, there will not be any acceleration. Okay, without that, which means that I am moving Q naught through a distance dr without any acceleration. Okay, by applying a force F external such that it counterbalances the force due to the electric field. Are you following? Okay, very, very important. Okay, therefore, some work has to be done in order to move, okay, through a distance dr. Some work has to be done by the external force. Okay, therefore, small work done in moving. Okay, in moving. Charge Q naught through what distance? dr. Through dr. That is nothing but, let it be dw, small work done. And that is equal to, what is that? F external. This is the direction of F external. Okay. F external dot, what is that? It is dot dr. This is the work done. Are you following? And that should be equal to, let me write here, that should be equal to, okay, this is nothing but minus of Fe negative dr. Okay, work done by the external force is negative of the work, what is that, done by the electric force. Okay, electrostatic force, that is electric field, that is electric field, that is it is, what is a repulsive force, no? Force due to the electric field, that is Fe. Okay, right. But now what I want is, I want to move, okay, Q naught from A to B, from A to B, from A to B. Okay, therefore, work done in moving the charge Q naught, okay, from where? A to B, where B is closer to the source. Okay, A to B. Therefore, that is nothing but work done, WAB, and that is equal to, you can say, integral, okay, A to B F external dot dr. Okay, and that is nothing but integral A to B minus Fe dot dr. Fe dot dr. Are you following? Okay, therefore this is the amount of work done in moving a charge Q naught from what? A to B, from A to B. Is it clear? Right. Now coming to the point, see, when a charge, recall what is that we have seen already in a gravitational field, that is, if a charge Q naught is kept at A, it acquires some electrostatic potential energy. Okay, and therefore, and when each and every point, when a charge is kept at any point in electric field, it acquires what is an electrostatic potential energy. Are you following? Therefore, what is that? Potential energy. Now we are moving the charge Q naught from A to B. At A, what is the what should be the potential energy? That is which potential energy? Electrostatic potential energy of the charge Q naught at A will be UA. Okay, and the electrostatic potential energy of the charge Q naught at B, let it be UB. UB. Are you following? Now, okay, when a charge Q naught is moved from A to B, okay, by the external force without acceleration, okay, therefore some work has to be, you know that the work, some work is done by the external force, work done, that is very important, by the external force, correct? By the external force. Small work done here also by the external force. Okay, so work done, therefore what is that? There is some work done, okay, in moving by the external force in moving a charge Q naught from A to B, and that work done is stored in the charge as the extra potential energy. What is extra potential energy? Because already it was having, when it was at A, it is having some, what is that? Potential energy UA. When you are bringing it to B, okay, therefore that extra potential, what is that? Because I am coming closer to the positive charge plus Q. Okay, therefore what is that? Its potential energy is increased when I am bringing the charge Q naught from A to B. How the potential energy is increased? At the expense of work done. At the expense of work done by the external force. Okay, when, what is that? When it is moved from A to, when the charge Q naught is moved from A to B. Are you following? Therefore, this work done is stored as, what is that? This work done is stored, okay, as, what is that? The extra electrostatic potential energy, okay, electrostatic potential energy in charge Q naught. Okay, therefore what is extra potential energy? That is a potential energy difference, that is delta U. That is extra potential energy here, nothing but delta U, that is nothing but UB minus UA. UB minus UA. Okay, when a charge is kept at any point, at point A, Q naught test charge, it has energy UA. When it is brought to B, it has potential energy UB. Therefore, what is that? UB is here, UB here is larger than UA. Why? Because the charge here, source charge is plus Q. Therefore, B is very closer to plus Q, means definitely what is a UB will be more than UA. So, on bringing the charge Q naught from A to B, okay, what happens? There is some change, increase in the potential energy. Okay, that is increase in the potential energy of the charge Q naught. What is that increase here? What is the, therefore difference? Difference is UB minus UA, and that is nothing but, what is that? It is nothing but the work done by the external force in moving the charge from A to B. Are you following? So this is everything. It is not a new concept, only everything you will have learnt in your 11th standard with respect to gravitational field. Okay, right. Now I want to define now. Therefore, okay, this, what UB minus UA is nothing but the potential energy difference, correct? Potential energy difference UB minus UA. What is that? It is nothing but the potential energy. Well, which potential energy? That is important. Okay, everywhere potential energy means, here it is very special. It is electrostatic potential energy. It is nothing but, okay, the electrostatic potential energy. It is nothing but electrostatic potential energy, what? Difference of the charge Q naught between, what is that? A and B. Between points. Between points A and B in electric field. Electric field produced by of charge क्या है? Plus Q. I think I'm writing everything. See, electrostatic potential energy difference of the charge Q naught between the points A and B in electric field produced by the charge of plus Q. Are you following? Plus Q here, according to this diagram, it is source is plus Q. Clear? Okay. Therefore, now I am going to define. See how to define from this only. What is a? It is what is that? The electrostatic potential energy difference. Okay, of a charge, of a test charge. Okay, between any 2 points. Between any 2 points. Between any 2 points means what is A and B here? Okay, between any 2 points. Okay, in an electric field. In an electric field. Yes, defined as the work done by the external force in moving that charge, moving, what is that? That test charge from one point to another without acceleration. Without acceleration. That without acceleration is very important. Once again, I repeat, it is, what is that? The electrostatic potential energy difference of a test charge, test charge between any 2 points in an electric field. In an electric field. Yes, defined as the work done. Okay, the work done in moving that charge from one point to another. Okay, without acceleration. Without acceleration. Okay, so this is what is that? Electrostatic potential energy difference of a charge Q naught. Here a charge means what is that? Q naught, test charge between any 2 points in an electrostatic field. Okay, is defined as the work done by the external force in moving that charge from one point to another without acceleration. Without acceleration. Are you following? Right. Now next one. So the next one is, see, now you have studied what is electrostatic potential energy difference, right? But now what I want is, I want electrostatic potential energy of a charge, okay, at any point in electric field. Electric field. So far what you have said, electrostatic potential energy of a charge, potential energy difference of a charge. Okay. But here we are going to say electrostatic potential energy of a charge. Just now we have seen what is that? Every point, see, if I have a charge plus Q here and I want to, here is my, what is it, A and here is B. Okay, therefore what is that? The delta U here, the potential energy difference between, just now we have seen delta U, that is equal to UB minus UA, that is nothing but work done in moving the test charge from, what is that, from A to B. That gives you the potential energy difference of the charge between the points A and B. But what I want is, I just want to find out the electrostatic potential energy of the charge Q naught at B. At B. Okay. So I don't want the potential energy difference. I want the potential energy of a charge at any point in the electrostatic field. Okay. Therefore, what should I do? And see, here 2 points, but this point is, first initial point is A. In the previous case, for finding delta U, A is very well within the electric field produced by our charge. plus Q, source charge. Now what I am going to do, because I don't want A is in middle, but why here? I want to find out the electrostatic potential energy of charge at B only. So what I am going to do here is, I am going to see, keep A somewhere outside. This is my A. Outside the electric field. I am choosing the point A outside the electric field. Okay. Therefore, what is my aim? I want to find out the potential energy of a charge Q naught at B. Electrostatic potential energy of a charge Q naught at B in a electrostatic field produced by a source charge plus Q. Okay. Therefore, what to be done? Keep Q naught here. Keep Q naught here. Okay, the test charge. And okay, from there what it is, you are bringing the charge. What is that? A is outside the field, outside the electric field means it is considered infinity. Why at infinity means, what is it? It's outside the field means there is no influence. Plus Q doesn't have any influence, okay, on this Q naught which is kept at A, which means that it is outside the field. Okay, outside the field is taken as infinity. Okay. Therefore, now how much amount of work has to be done in moving a test charge from infinity? A is nothing but infinity. Infinity to that point where I want to find out the potential energy of the charge. Okay. Infinity to that point without acceleration. The amount of work done, okay, in moving the charge Q naught from infinity to that point without acceleration gives you the potential energy of the charge at where? B. That is at that point. Okay. Therefore, I hope you are following me. What is that? You are taking A here as infinity. A is at infinity. A is at infinity. Therefore, now it is the amount of work done in moving a charge. What done by what? Either external force. In moving the charge from where? From infinity to that point. Which point? B. To that point. Okay. Without acceleration. That gives you UB minus, what is a U infinity? A is at infinity, na? That is nothing but UB infinity. Doesn't have any influence, na? Though it is 0. Okay, because it is at infinity, potential energy, plus Q is not having any influence on it. Therefore, you will get UB. You will get UB here. Okay. Hope you are following. So, this gives you what? The potential energy. This is nothing but potential energy. Which potential? Electrostatic. Electrostatic potential energy of the charge. Okay. At the B. At B. At B means what? At point B. Okay. In an electric field produced by source plus Q, source charge plus Q. Are you following? Okay. Therefore, now once again, what is that? Define this. What is that? Electrostatic potential energy, okay, of a charge at any point in an electric field. In an electric field is defined as the work done by the external force in moving that charge from infinity to that point without acceleration. Without acceleration. Okay. Therefore, what is that? The charge is A test charge, definitely. Why? But it should not have any influence on the electric field produced by our source, that is plus Q. Okay, that is very important. Therefore, what is that? Electrostatic potential energy of any charge, of a charge at any point in an electric field, okay, is defined as the work done by the external force in moving that charge from infinity to that point without acceleration. Without acceleration. Is it clear? Okay. Therefore, this is about, what is that? Electrostatic potential energy and electrostatic potential energy difference of a charge. That is, both we have seen. Potential energy difference also, and potential energy of a charge. Is it clear? Okay.